Okay, so our next speaker from the PETSc developer is giving us kind of an update or an introduction to how things work. Is Satish Balay, who's been with the PETSc project almost from the beginning. He's our maintainer that keeps everything working, and he's going to give us a talk about how to interact with the Git workflows if you're thinking about contributing to PETSc. Thanks, Satish.
Thanks, Toby. Hi, everyone. So I'm just going to talk a little bit about the PETSc software side of things, where some of the workflows we have with the developers, as well as how we interact with all of you when there are merge requests and so on and so forth. So just a brief outline, mostly about Git and merge requests and running test suites and a little bit of history, I guess. So as probably everybody knows this, our primary repository is at GitLab, and we have two main branches in Git that we work on. One is a main branch, which gets all the new features or any API changes, any major code changes goes into main branch. And the other branch we have is release, where once we have a release, any bugs that are found there or any website documentation issues, all those changes go into the release branch. So we have slightly different workflows for Fortran and Python interfaces, because the primary interface is C. Any changes in APIs on the C side, but any changes on the Fortran and Python side basically are fixes to make it in sync with the C interface. So some of those changes can go into release. And we also maintain branches for older releases. Whenever there's a new release, old release are kind of accessed through branches. Occasionally, they are used. And then, during normal workflow, we create our own branches for new features or fixes, and then we go through testing process, and then they get merged in. So the repository is all the primary branches and all the development branches. And I have a URL down below which kind of describes more on the website documentation about some of these features. And the release schedule. So we tend to have a release every 6 months, and the release consists of all the new changes in PETSc. Apart from the 6 months release cycle, usually it's in March and September of every year. We also have monthly patch updates when we have bug fixes and so on and so forth. So if you're using a particular release, it's best to use the latest bug fix release, and that should work without any code changes on your end. And that's a goal. And in some sense, that's a model for most software where you want to be able to replace the lower layer of dependency without recompiling the higher level. And we hope we are doing that. There are no tools to verify it, but the current model is to just keep the bug fixes to be just bug fixes without affecting user code. The other part is that because of this two-level workflow, when the bug fixes go into the release branch, they also get merged into main periodically. So all the bug fixes first go into release and then into main. But all the changes in release in the main branch get released at the end of the 6-month cycle, and all this gets synced into the release branch at that point. PETSc for Pi, it's also part of PETSc now. It used to be a separate package and is distributed separately. But now if you install PETSc, you also get PETSc for Pi. But we still maintain the old model by also spinning at PETSc for Pi tarball. Like if you install PETSc for Pi from pip, it's using that separate tarball. So you get PETSc separately and PETSc for Pi separately.
Can I ask you, so say that we make a fix to PETSc for Pi, how does the Pi PETSc for Pi get updated?
So when we make a release, we have a PETSc tarball as well as a PETSc for Pi tarball.
Okay.
And both of them need to be uploaded to PyPy, because PyPy has a representation for both PETSc separately and Petsy for Pi separately.
Okay, and who, are you doing that now?
Lissandra used to do that. Now I'm doing it. He said, "You."
Okay.
So when I tag a release, the tarballs are spun, and the tarballs are available on our website as well as uploaded to PyPy,
Okay.
and then also to SPAC.
Okay.
So that's my release workflow. Okay. So with that organization we have, the contributing to Petsy has a workflow that kind of guided by the two branch model we have and the release model we have, and we encourage everyone to make a contribution, and so a lot of these processes are documented in the website. But just to briefly go through that process. So caveat, the first one is a caveat that contributing basically, all contributions comply with the Petsy source code license. So that's something, it's upfront in the merge request process. And then the Git lab model is that only developers have access to the primary repository. Every other contributor has to make a fork of Petsy repository and make changes in that fork. And the documentation explains how it is done, but briefly, everybody would need a GitLab account to be able to fork Petsy and then make changes in the fork. It's best to make a change in a local branch and not to main or release branches. So since we have this two branch model, if a change goes to release, it's good to start this new branch from release, and you just do a git checkout release and then create a branch of that. And if the change goes to main, based on the previous discussion, you would just start a new branch of main and make your changes and commits on this branch. And then when you push your branch to your fork, Git basically gives you a nice message saying that this is how you can create a merge request. So you can just click on that, and that would create a merge request. Or you can go to the merge request operation on the GitLab website, and that's one way to create a merge request. And the only key thing here to remember is, okay, I have this branch. The merge request destination is either release or main, has to be decided a priori. Sometimes it's okay to forget about it, but that's one thing that GitLab tries to make sure that we do. And then create a merge request. After the merge request is created, then there's a little bit of review process and then testing, and then other processes. The thing I was going to mention here is that most of these processes are available to developer group, not to folks who are not in the developer group because of permission issues, GitLab imposes, and so on and so forth. So there's some communication involved which is not easily pre-set up by the merge request author. So what we normally do is, like, one of us will notice that there's a new merge request and then follow through. And this GitLab also provides a shortcut to avoid this whole process. You can just go to the web page and click edit and edit it on the GitLab website, and then just submit a merge request from there. So you don't even have to create a fork and go through the whole process. It actually creates a fork in this whole process. So just to quickly demonstrate, let's see if I can do this. If I go here, I think it has this edit option here for this source file in this repository. I can just do edit a single file, open an IDE, and I think once you edit it, it gives you an option to submit a merge request. Okay, so let's see how do I go back. Maybe I'll move this to this side. So once a merge request is created, we have like basically 4 stages. One is like first we test the merge request. We use GitLab pipelines to do most of the testing. It tests various combination of things, configurations, operating systems, compilers, GPUs, and so on and so forth. And there's also some testing for code styling. Like we are out with Clang format now to check and comply with the code rules. And that's a little bit automated now. Previously, there used to be quite a bit of contention. Oh, I like this format, I like this format. But now Clang format just forces everybody to use one format. And then we build the documentation as part of the testing, which eliminates a lot of other issues. And then reviews, like there are code owners for different parts of PETSc sources, and they like to make sure things are okay from their point of view. So there will be review comments, and once those comments are resolved, that's when the merge request is ready for merge. And one thing I'd like to make sure is the commit history is clean, so that future when you have to debug issues or use Git bisect or actually read code, it's sometimes easier to read the diff and comments. So I always ask folks to clean up the history, add in proper comments to the commit messages, and have them incremental commits instead of one giant commit. So that's one thing. And then I make the merge. So,
Satish,
yep.
you said you need to make the commit history clean and then do Git bisect. I wanted to know whether we need to make each commit compilable and functional.
Yeah, so
Very hard.
So we do have that, like for example, maybe I'll go, this is a merge request, one of the merge requests that's currently in progress. And these are the pipelines over here. And if you go to one of and the pipeline runs like 74 odd jobs. So one of the tests is check each commit. So this guy basically checks out each commit in the merge request, make sure it compiles the whole PETSc.
So it's not going to run the full test suite, but that is going to check each commit for just the library.
So let me go to, let's see if I can.
That's enough to bisect.
Let me see if I can go to one of the completed ones. Oops, I can just go here, I guess. Sorry, this navigation is taking a little bit slow. So I go to Pipelines tab here. So this is a completed pipeline. Stage 2, check each commit. So.
But this MR only has one commit, so that's easy. If you have MR has 10 commits,
So
it does 10 builds for each commit.
So I've done recently like some big changes where, I would like to have consistent, legible Git histories, but it's a big change, and so I've got a few commits, and so it will be one of the longer stages. And so on the one hand, that's some encouragement to avoid big monolithic changes, right? If the change you're trying to make is turning into like 15 commits to explain it, you might want to try to break it up. But I think there also might be some things that we can do with a little bit of work to accelerate check each commit. Like right now, it does a full recompile from git clean FDX, right? Where as opposed to, it may not be perfect in terms of being able to do git bisect, but if we just did kind of an incremental make, reconfigure, make, it might be possible for us to do check each commit a little bit faster.
Yeah, but the other flip side is if you have 20 or 30 commits, it's probably needs to clean up anyway. You might as well clean up before the merge request is ready.
Or split it into.
But it is right now where if that doesn't pass, you get the yellow exclamation point as opposed to the red X. So we're not gonna spike the pipeline if it doesn't.
Yeah, so the reason is maybe it's going to be squashed into a single commit later on anyway. If that's the goal, it's okay to ignore that one job.
do
you have anything talking about like git auto squash or git auto fix up?
I don't, but what I can do is just go back to this merge request.
Just at the end, I might show people that as a way to work with this kind of work.
So in this merge request, there's only one commit though, but still, like if everything is clean, there's a squash commits option that I get, and this is what I can use. You as a merge request author can indicate in the merge request that the commit needs to be squashed.
And as long as we're all here, everyone should be marking delete source branch when done. Don't leave your branches in there.
Let me ask actually a question. So I actually never click the squash commits when merge request is accepted and prefer to do the squash myself so that I can write a coherent commit log that kind of summarizes, what maybe was in the 10 commits. What actually happens with the commit log when it automatically does that?
So when I do this, what happens is if I try to do a commit, let's see if I can get to this. Cancel. Leave page.
So if you squash and rebase, it does that too.
It doesn't do a rebase, it just does a squash.
Yeah.
So the options I get is edit commit message over here as a merge.
Okay.
And here, by default, it picks up the commit title for the merge commit. And then for the squash commit, this merge commit is here. It picks up the title, and then it puts in this link back to the merge web page. And for the squash, it picks up the first commit message from, if you have 10 commits. And then I can choose any one of the commit messages and edit them. So yeah, if I do it, I might not do it right. So if you do it by cleaning up the commit history.
This always ends up with the. Okay. Yeah.
So if I have to do it, I just pick up the first commit message.
Okay.
By default, it just puts the merge request header in both locations. And I get to choose if I want to pick up the first commit. So here I can do first commit. It has a little bit more information. So a lot of merge requests don't have good commit messages. I'm hoping that improves.
I always just have considered for myself best practices to when I'm really ready to merge the thing, I do an interactive rebase. I squash the things that make sense. Then also it makes that final merge usually go a lot easier if I've done a recent rebase.
And that's preferable. And a lot of times, like Barry says, like, oh, at the very end, I don't know how to clean up.
But it was really tricky. I mean, I struggled a lot really learning how to do a good interactive rebase.
Yeah. So my hope is like as you add one new commit, you clean up all the 10 commits you have before, and the next commit clean up. So it takes a little bit of work, but that's the best time to actually clean up because once you accumulate so much commits, it's hard to know which one goes where.
When I do that last rebase, I'm usually changing the order of the commits, how I want them to apply in the rebase.
Yeah. So I like that as in like I prefer like if a change is usually not a single change. It's like, okay, I need this new feature in PETSc for this main feature, or I need to fix this bug in PETSc to have this main feature. And usually you detect those issues like after adding 3 or 4 changes. So I'd like to reorder them and say that all the basic dependencies should go at the bottom, and then my new feature comes after that. Bug fixes go first, then, hey, improvements to the current feature, and I'm using these two in my new feature. So I would like to reorganize all the commits that way.
So
but,
I have always
it's hard to impose that.
Been splitting the tests from the feature implementation. So like I'll do feature implementation, then another commit for tests of implementation or changes to existing tests.
Yeah, sometimes I feel like feature and test can go in the same commit. It's fine to be separate, but it can also go in the same commit. But sometimes a single feature can be incrementally added, and then add the test. So if it's a huge diff, it's hard to read, but when you split up in incremental changes, sometimes it's easier to read. And that would be one reason why incremental changes to a single feature might be beneficial. It's ultimately about how easy it is to read and if you can build the whole library without breaking it. Cool.
I just, as an outsider, ask for clarification. So first you would like a pretty granular set of commits for the pull request, so that it's easy for you to review, and so that each commit is really, just a couple lines or something like that. And then if it's accepted, then you can squash and merge it, but you'd prefer it, like if we take Richard's approach, then after it's kind of approved, then we could do our own squash so that then you're just essentially doing a merge commit or a rebase onto the PETSc main of our squashed commit, or
I mean, normally I wouldn't do anything if the commits are already clean. I just merge it in and keep it, because if it's good for review, it's also good to be in the history.
So you'd put all the commits in there if they're nice and clean.
Yeah, if it's things I'd like to avoid is like, hey, first commit introduced a bug, second commit fixed the bug in the first commit, and third commit fixed some code change in the first commit. Those things I'd like to be squashed and cleaned up, because it doesn't make sense to preserve that buggy history. But if it made sense that, hey, if it's split up in this way, it builds fine, and it's easy to read, to review, it probably makes sense to look 6 months later and understand the feature with that split. So I'd like to preserve that. And oops, cancelled. Oh, there was something else I was going to say.
Let's not mess up Pierre's work just for.
Yeah. So what I was going to say is like, if you make such changes, GitLab keeps track of all those changes, like if you rebase, squash, and whatnot, and I can easily compare with the previous version. Like if it's just a squash, then a comparison with the previous version should show no diff. So I can easily verify that, oh, it's already tested, I don't need to rerun a pipeline. Whereas, and it's a good way to make sure all the reordering, squashing actually didn't make added any new code changes and errors. So that's one thing we can always do. Cool. I'm not sure where I digressed from, but it's good. Testing, yeah, so I just went through a little bit of the testing side of things. Artifacts, maybe I'll just go back and show that. So basically, the idea is that we do all those tests, but when there are failures, you can always get the logs on why the failures occurred, and then check the logs to investigate that or reproduce those builds locally. Ideally, everybody should have access to the build nodes so that they can easily reproduce it, but we don't have that right now. And so some of the things that are done in the pipelines is basically builds and runs, and this is some example of how to reproduce locally. Like you build with configure, make, check, and basically the CI is running all G test tab, but all test and all test T tabs is representative of the same thing. And then if you spot a failure, you can run that one test locally with this command, make test, search the test name. You can easily grab that from the CI output. And then, in fact, Juncha wanted me to add this in. The verbose option basically gives you the additional information exactly what PETSc is doing. So let me just quickly demonstrate that, if I can. So maybe I missed make. That's the reason. So let's start with the clean test. So this is what is run by the test suite. There's a script which goes through all the tests and constructs the list of jobs to run, compile, and so on and so forth. So it just takes a minute to do that. And then it starts, it starts with a basic cleanup, builds the object files, builds the library, not the library, but the binaries at some point, and then runs a test. So the test suite does everything in a single go. Let me do a clean. And just to show exactly, just running one particular test. So instead of running all the tests, here I'm just running one test. You can do wildcards here, where you can run a group of tests. And here it shows like a single compile of the object file, create the binary, and then run the test. It's done some comparison, and everything's successful. And to get more information, to see exactly what is happening. So these are kind of useful things to discover. And
You can give extra options,
Yeah.
extra underscore options. So I use the test system to run everything that I run.
Yeah.
I almost don't run anything by hand anymore.
So using verbose, it shows exactly the compile command it used. Sometimes this information is useful to debug, and the link command is used, and then it also prints the exact MPI exec command that is invoked, and then the diff command. So just to reproduce a test locally, this is useful. And to go back, and okay, so let's see pipelines. This is okay. So let's see which failed here. So here's a failure. I don't want to look at this.
Well, so good we're not failing the test.
Okay.
Oh, this is because we're all sitting around.
I'm not sure if it's the right failure I'm looking for. Maybe this one. Let's see if this helps. So this test failed. It's marked as red. And then, so it's, let's see, the reason for failure was a build error. So there was an error in the build. And so what I was going to point out is on the right side, you have the artifact section. And if you browse the artifact section, you can download them or browse them. And here, some of the logs from the build are available. So here, let's see, conf. So in this case, make log is a place where the relevant error is. But if there's a configure failure, the configure.log is available. So one can download and check. And if there are some missing logs, you can add more. So that's pretty useful for being able to debug without having access to the machines that run the CI. I'm not sure if I'm running out of time.
No, something happened. The Panamco just said that it can't detect the primary audio.
Oh, I think that's
Is it okay?
primary video or audio?
Audio.
Let me
That's
see.
what I was worried.
Let me see if it's still working.
Testing? Yep.
Yeah, but no, it's still working.
Oh, it's still working. Okay, good.
So,
Yep.
is it sensitive to small changes in like floating point output, these test outputs?
So Barry has a diff tool which ignores all the floating point differences. So when we're doing regression testing,
The answer is no, because we don't ever check any floating point numbers.
because every machine produces slightly different thing, so what we look for is iteration count change, or integers are checked, but floating point is ignored. Otherwise, we can't.
There are cases where the iteration count changes from machine to machine and what's happening is correct. So then we have like alternate, correct answer files that are checked in.
Or we rep out that line, which is done in some.
So I think
you can also do.
ideally, if you have the time, you would like to be able to, within your test file, set some kind of an error condition that makes sense, that we're not going to have to deal too much with that. When I have students who have tried to, when we have, we're testing an iterative method, if you have a test that relies on an iterative method that's going to go into the order of hundreds of iterations, that's going to get super sensitive, and so I want people to rewrite those tests. Like if the correct behavior is beyond order tens of iterations, that's going to be too hard to maintain. And so find a better way to test it is kind of what we want
Yes.
We kind of, like, when I do convergence tests, I round to integer. So it's second order, it's first order. And you'll get close, it'll be like 0.97 instead of 1. And rounding is pretty robust there. So you'll catch bad stuff. But
So let's give Satish a chance to finish so that we can not keep people from
Yeah.
oh, sure.
Yeah.
Sorry.
Sorry. This is a simple example of how to add a test to the PETSc code base. You can just drop in a new source file into a test or tutorials directory, and then right now the test suite basically requires formatted comments within the source code so that it's not in a separate location on how to run the test. The formatted comment is here, like for a simple test. Say, for example, if your test is basically running it on 2 processes and a couple of options, the representation is just, you just have some suffix so that you can have different tests. And then num size is 2, corresponding to the number of processes for PETSc, and the arguments. And then also add a corresponding output file in the output directory with the suffix and the file name. So in this case, ex65 underscore basic from the suffix .out. And Matt was mentioning like you can have basic underscore alt1, alt2.out if there are different, like single precision produces 10 iterations versus double precision only 5 iterations. And you still think that single precision data is valid. So we have alt file support for that. And you can add that. And there's a simple way of generating those files. All you need to do is run the test using the test harness and use a replace option. So you can avoid mistakes of copy pasting. It just creates that file for you. And the test harness does a lot more things, and most of those syntax is documented in the testing section of the developer's guide. And then there's a lot more documentation of PETSc design and coding style and developer documentation. It's good to go through, but it's not critical. What we want you to do is like have an easy process for everybody to submit merge request without getting stuck. So we just ask, it's great if you understand those things and submit a merge request, but either we just submit a merge request and then we can iterate and figure out those issues as the merge request progresses. And the critical part for merge request is code reviews. That's the one where things get a little bit stuck. Ideally, a lot more folks would need to participate in code reviews, and that would be good. And even if not contributing code, participating in code reviews might be something useful. Like, for example, if the code affects your usage, you might want to look at it before it gets merged. Brief history, I just thought I should add this series. Since this talk is about Git, so we started using other tools before Git. And I think Barry, I don't know when Barry started using RCS, but PETSc 1, I don't know when the PETSc 1 date was.
Day 1, I started using RCS.
80s?
September 1994.
90, yeah, so the current history has 94, but I wasn't sure PETSc 1 history when it started.
No, that was some files that sit in Bill Grumps.
So PETSc started using RCS with Barry, Bill, and Lois, I think. And then when I joined, I was like too many developers working the same directory. So at some point, we just revised it so that multiple folks could edit RCS files and do multiple builds. And then we never used Serious because at some point Barry had super bad experience with it. And then
Great stories.
So this worked until Matt came. He's like, I can't work in this way. And then and they said, oh, this greatest tool since sliced bread came called Mercurial. And he migrated all of us to Mercurial. And then due to licensing issues like Linux, Mercurial, folks had this big argument, and then Linus went and created Git. At the same time, there were a bunch of folks who created other tools like Arch. And at the time, we thought Mercurial user interface was understandable, but we didn't understand Git, so we migrated to Mercurial. And then that's when distributed version control started, and then we had a hosting server. We hosted it locally. And then when Sean joined, I think he was like, we need to be on Bitbucket. Or I don't know if it was Jed or Sean, but for sure, Sean did the migration to Bitbucket. And then at some point, Jed was like, okay, we need to have this overhaul our workflow and use GitWorkflows with the main branch and next branch. You need to be able to test things before they get into main master branch. So we need to use Git for that and set up the testing with that. So that's happened in 2013, looks like it. And then at some point, our testing was kind of crumbling. And Jed said, okay, we need to use GitLab for CI. And that's when we moved to GitLab. So anyway, brief history. I'm sure I'm missing quite a few things in here. And we have plenty of channels for communication. And if any issues come up, that's always good to interact and discuss and resolve. Thank you.
It would be fun if someone had a screenshot of Carl's old dashboard for tests that we used before we had our GitLab CI.
Oh, yeah.
That was check in the morning after the night leads, that pattern.
Oh.
Everything's red.